Everybody, I told you I was going to be gone, so we're going to try this video note today. Okay, so I know we won't have time to go over these two problems before we get started, so make sure as a group, if you guys struggle with 59 and 60, at the end, if you have time after you work on your homework, go back over these and make sure you write down any questions you have, or you make sure all of your answers match up, and then we'll talk about them tomorrow when I get back into class. All right, so lesson 1.6. This is going to be about angle pair relationships. Okay, so we're going to have a couple things happening here. You're going to have a couple sets of angles that are always going to be congruent, and we're going to work with these a little bit using some algebra. Okay, so I'll move this guy. All right, so the first thing we need to talk about is what it means to be complementary and what it means to be supplementary. So hopefully these are going to be a little bit of review for you. The biggest thing is just making sure you remember what number goes with which word, okay? So you know, hopefully, that complementary, those are angles that equal 90 degrees. And then supplementary, those are angles that equal 180, so they add up to give you 180. Okay, so hopefully those are the two things you remember from being complementary and supplementary in algebra. Okay, so supplementary angles, you can write your own definition, or you can just say two angles that add to 180 degrees. Now, with supplementary and complementary angles, they can look two different ways. They can be adjacent, which is right next to each other, so this picture here. And they can also be non-adjacent, which means they don't have to be touching, but they still can equal 180. You would just take this angle plus this angle and say those are adding up to give you 180. And then with them being supplementary and adjacent, you see here that those two would add up to form this straight angle, which 180 is. It is a straight line, okay? So complementary, two angles that add to give you 180, and then they can be adjacent, which just means they're right next to each other. They share that common ray, and that they can be non-adjacent, so they don't technically have to touch, but they still could form 180 degrees. All right, complementary, well, we know the number that matches up with that is 90, so you can say two angles that they add up to give you 90 degrees. And the same thing goes for complementary, just like supplementary. So complementary angles can be adjacent and they can be non-adjacent. Like we talked about before yesterday, make sure if you have 90 degrees anywhere, anytime on a problem, you need to make sure you mark that right angle. Okay, so then these two over here are the complementary adjacent angles, and then these ones that are not touching, those are the non-adjacent. Okay, so touching versus not touching, adjacent versus non-adjacent. Okay, so now you're just going to find the complements and the supplements, which means you're going to be given one angle, and then you're going to use the idea that those two together add up to 90, or those two add up to 180 to go ahead and solve for the missing complement or supplement. So, given that angle A is the complement of angle C, and we know that the measure of angle A is 47, we want to know what angle C measures. So anytime I have a problem like this, complement or supplement, I automatically put the number, just so I know for sure I get that correct. So then I say the measure of angle, put an angle sign in there, the measure of angle A, well that is equal to 47. So I'm just going to plug that in, the measure of angle A plus the measure of angle C, that's going to be equal to 90. So I will just go ahead and plug that in. So 47 plus the measure of angle C is equal to 90 degrees. Okay, so then it just becomes a simple one-step problem. So 90 minus 47, so the measure of angle C is equal to 43 degrees, and that's your answer. That's the complement of 47, because 47 and 43 together will give you 90. Okay, so hopefully that makes sense. Same thing goes for a supplement. Anytime I see the word supplement or supplementary, I'm going to plug in 180. So now the measure of angle P plus its supplement, angle R, is equal to 180. And I know that angle R was given to me to be 36. So the measure of angle P plus 36 is equal to 180. And then again, it just becomes a one-step problem. Subtract 36 from both sides, and you get the measure of angle P to be 144, and you're good to go. Okay, so it's really just plugging in. It's almost like a segment addition problem where your totals, or excuse me, angle addition problem. Your totals are those 90 and the 180 degrees, and then you're just adding the other two. Okay, so hopefully that makes sense, finding complements and supplements. All right, this one is the exact same thing, but it's going to be more of a word problem. I know those are your favorite. Everybody loves word problems, and I'm sure we're getting a lot of eye rolls right now. That's okay. All right, so let's read. Angle W and angle Z are complementary, which means they're 90. They add up to 90. The measure of angle Z is 5 times, that's going to be very important, the measure of angle W. Let's find the measure of angle W. All right, so I'm going to start out by saying the measure of angle W plus the measure of angle Z is equal to 90 degrees. Okay, that's an easy place to start. But I don't have numbers to plug in. I know that angle Z is going to be 5 times, so that's multiplication, 5 times bigger than the angle W. Okay, so I'm going to think of it this way. I know angle W is going to be some number. Okay, I don't know what it is, but I know it's going to be something. And then I know I'm going to add on the measure of angle Z, but angle Z is said to be 5 times the measure of angle W. So I'm actually going to add 5x. Okay, 5 times, so I know I'm multiplying. If it were to add, so if Z needed to be 5 more than, that's when you would add. Okay, so a dead giveaway when it's multiplication, times. All right, so then that's equal to 90. Now it's just a simple add and divide. So 6x is equal to 90. Divide by 6. So hopefully you all know what the answer is. So 90 divided by 6, we should get 15. Okay, but again, that is not my answer because it's asking me to find the measure of angle W. Okay, so I don't want to put a degree symbol there until I for sure know I've plugged it into the correct spot. Well, in this case, you actually do get to put a degree symbol because that is what x is. So the measure of angle W is equal to 15 degrees. Okay, so that is your final answer there. And then if they wanted angle Z, you're just going to plug it in for that 5x and call it good. Okay, so hopefully that makes some sense. All right, so still continuing with the idea of complementary and supplementary finding angles. Anytime I see complementary, I'm going to put that number at 90 degrees, okay? A and B are complementary, but we don't have numbers. We have expressions, okay? But I do know that the measure of angle A plus the measure of angle B is equal to 90, okay? So let's think about this. If I know that, if I know A and B are complementary, I get to automatically write that every single time, okay? So then all it becomes is a matter of plugging in the right thing. So anywhere I see the measure of angle A, I'm going to plug in 3x minus 7. Okay, I'm going to put that in parentheses. Then I'm going to add in the measure of angle B. So in parentheses, 11x minus 1. That's equal to 90 degrees. So hopefully you're asking yourself, why do I have to put that in parentheses? And hopefully some of us are going to say, because if we have to distribute, we need to make sure we distribute correctly. Okay, so I always want you to put anything you plug in I want you to put it in parentheses, okay? I don't have to distribute, so I can just combine. So 3x plus 11x, that'll give us 14x. And then I have negative 7 minus 1. So negative 7, and I take away 1 more, I'm at 8. That is equal to, that's a 0, 90 degrees. Getting ahead of myself. All right, so now it just becomes a one-step or a two-step equation. Add 8 to both sides, so 14x is equal to 98. Then I just need to divide by 14. So then x is equal to 7. Okay, but again, I don't want to put a degree symbol there because that's only what x is. So I need to go back and I need to plug it in for A and B. So the measure of angle A in red here is 3 times 7 minus 7. Okay, so 3 times 7, hopefully you're saying to yourself, that is 21. And then when I subtract 7, I should get 14. Now I can put a degree symbol for the measure of angle A. And then the measure of angle B, that will be equal to 11 times 7 minus, that's a 1, minus 1. So now I have 77 minus 1, which is 76, and I can put a degree symbol there because I am done. And then 76 plus 14, always double check with your calculator or mental math. Make sure you're adding up to 90 to double check that you're not doing any math incorrectly. And if not, you're good to go. Circle your answers. Okay, so that's just finding angles if they're complementary or supplementary, just with a little bit more algebra in them. So hopefully they're still pretty straightforward for you. All right, vertical angles. Using the diagram below, let's figure out what vertical angles are. So on the screen, it does tell you. Otherwise, I would have asked you in class to try to figure this out. So hopefully from Algebra 1, you kind of remember this concept. If you don't, that's okay. We're going to go back over it. Okay, so vertical angles, I always think of a mirror image. They're basically the exact same size, just in a different location. They're basically flipped upside down. Okay, so those two are vertical angles, and then 1 and 3 are vertical angles. Okay, so they're basically the exact same, just in a different location. Okay, so hopefully that makes some sense. Now, something special is going to happen with those vertical angles, and you might already know from Algebra 1. Those of us who forgot, that's okay. We are going to look at a file here from GeoGebra. So let me pull this up. Okay, so we see here, we can show angle BEC. Oh, I gotta click on the computer. Okay, so there's angle BEC, and it'll actually show you the measurement. Okay, so its vertical angle should be, hopefully you guys all said angle DEA, so I'm going to show that one, and notice what their degrees are. Okay, they're the exact same, 128.19. Okay, and I can move all of these around. I can change it up, but anywhere I put it, those still stay the same. They're just in a different location, but they still stay the same degrees. Okay, so I'll unclick those. And then if I click angle BED, its vertical angle should be, hopefully you guys are all saying angle CEA, so we'll click that. And then those end up being the exact same. They're just in a different location. Okay? So vertical angles, just think of a mirror image. Okay? Anywhere I move them, I don't care. They are always going to be the same. Okay? Hopefully that makes sense. And hopefully some of us remember that from Algebra 1. All right, let me go back to this slide. So the conclusion we're going to make about vertical angles is that they're going to be, hopefully you're saying congruent, because that's exactly what they're going to be. Okay, so if they are congruent, so vertical angles are congruent, let's go ahead and use that idea to solve for x and y in this case. Now, you can put those arc measures, okay, so those arcs mean that they're congruent. So if those are in the same, or they're the same size, just in a different location, they're vertical angles. So because I concluded that they're congruent, I can go ahead and take 5y plus 10, set it equal to 6y minus 2, and I'm just going to solve for that. So move stuff to the same side and then divide. So add 2, subtract 5, subtract 5. So I'm kind of doing it all in one step. But I'm going to get 12 is equal to 1y because I have 6 minus 5. So y becomes 12. And what you can always do to double check that you're getting the correct value, plug it back into both equations, or excuse me, expressions, and double check that you get the same answer. So I can plug it into the 6y minus 2. So 12 times 6 is 72 minus 2. That should be 70 degrees. I'll plug it into the 5y plus 10. Well, 5y times 12 is 60 plus 10. I get 70 degrees. So I know my y value is good to go. Okay, this one for the x is even easier because you only have one side that has a variable. So we say 2x plus 40 is equal to 110. Two-step equation, subtract 40. Then I have 2x is equal to 110 minus 40. And then what is half of 70? Well, that is 35. Okay, so I know this top angle up there where those dots are now, that is 110. So if I plug in x here, I should in fact get 110. So 35 times 2, well, I know that's 70. So then if I add 40 to that, I sure do get 110. So this is the correct y value. Okay, now I do want to point out something with these. Okay, look at those and then look at these. Is there another relationship that you see other than vertical angles? We got two 110s and two 70s. Hopefully some of us are thinking, if I add 110 and 70 together, I end up getting 180, and there's a reason why that happens. And it's because of this reason, the linear pair. So drawn here is an example of a linear pair. Linear, we remember that means line, okay? So it's two angles that add up to give you 180. So it's basically the idea of being supplementary. But this time, they're always going to be adjacent, okay? So you can assume from this diagram that two adjacent angles will form this linear pair. As long as the linear pairs, so 5 and 6, as long as they lie on the same line. Okay, so basically here, we're going to have the measure of angle 5 plus the measure of angle 6 is equal to 180. They are a linear pair. They form that straight line, or the semi-straight line I just drew. Okay, a counter example, well, an easy one, if they're not a linear pair, I could say that they're complementary. Those will not form, they'll form half of a line, they'll form 90 degrees, but it is not a linear pair because they don't form a straight line. So there's a quick and easy counter example. Okay, you could also say they're non-adjacent. That would be something here that would fail because it says now they are two adjacent angles. Okay. Okay, so hopefully linear pair makes sense. Just remember linear means line. That's bottom line. Linear means line. A straight line equals 180 degrees. Okay. All right, so we kind of already said this. I'll show you again one more time in GeoGebra. Pull this back up. Okay, so if you look, I'll try to get some nice numbers here. Let's get as close as possible. Maybe not. Okay, so 63.8, and then let's add in these other angles. Okay, so these two angles right here where the cursor is going over. If you were to add those up, you should get 180. Okay, how many linear pairs do I actually have here? How many linear pairs? Okay, hopefully everyone's seeing 4. We have these two, AED and BED. We have these two, AED and AEC. We have these two down here, AEC and CEB. And then the last pair on the right side here, CEB and BED. Okay, so we actually have 4 pairs of linear pairs. Basically, we can kind of go around almost in a circle. Okay, so hopefully you understand linear pairs, they just form a line. Okay, all right, so let's solve for x and y and then find the angle measures. Okay, now it's not going to make sense to take these two. I would hope not, at least, because if I were to add that together, I would have an x and a y in the same problem, and that's just going to make life complicated. So always double check which two you can add together easily, and I can do those two. So I can say 3x plus 5 plus x plus 15 is equal to 180 because they form a straight line. Those are a linear pair. So then it's just a matter of solving this. So I have 4x plus 20 is equal to 180. So if I subtract 20 over, I get 4x is equal to 160. Divide by 4, x is equal to 40. Okay, that is not your degree though, you got to plug that back in. So if I plug it into this top angle, AED, I have 3 times 40, so that'll give me 120, and then I add 5, this should be 125. Okay, and there's a couple ways to go to figure out this next one, angle BED. You can take 180 and subtract 125, or we can just plug 40 in. Either way you go, you should get 55 degrees. Okay? All right, then there's a couple of ways to solve for the last 2 angles, but I'm just going to be consistent for now until we get the linear pairs down. So all I'm going to do is I'm going to do the exact same thing just with the y's. So y plus 20 plus 4y minus 15. Okay, and I didn't have to distribute, so I'm good without those parentheses. Okay, so now I have 5y plus 5 because 20 minus 15. That's equal to 180. Then I take 180 and I subtract 5 and I get 175. So 5y is equal to 175. And then divide by 5, I get y to be 35. And again, that is not the total answer. You plug that back in. So over here, my y being 35 plus 20, I should get 55. And then when I plug it into here, 4y times 35 is 140. But when I subtract 15, I get 125, which matches up with the other numbers. Okay, so that's one way to do it. I understand there's probably an easier way, but we'll talk about that tomorrow. Okay, go this way for now with the linear pair. Okay, so I know we went through that quickly, so just take another second to finish up writing it or to look at it to see if you do have any other questions. If you do have a question, please make sure you star this slide and we can talk about it tomorrow. Okay, or you can ask your group too. That's what they're there for. All right, there is your assignment for tonight. Okay, so start on this. Hopefully you have a little bit of time to work in class. Work together. Please make sure you stay on task. The other thing is, remember, tomorrow, Wednesday, it's a review day over Monday's material and today's. And then Thursday we review all of chapter 1 from last week, and then Friday we take our first chapter test. Okay, and remember it's pep rally schedule, so we're only shortened by a couple minutes, but you gotta come ready to go. So hopefully this worked out well. Again, if you have any specific questions, we'll address them tomorrow when I'm back. Have a great day. We'll see ya.